Imagine this. You're standing in your kitchen, half awake, watching coffee drip into a cup. The liquid looks almost black, deep, dark, opaque. And then you glance at the coffee beans on the counter. They're brown, not black, not even close. And suddenly, a simple question feels surprisingly strange. If the bean is brown, why does coffee turn black? It's one of those things we see every day and never question, the kind of detail your brain files under normal and moves on. But once you notice it, you can't unsee it, because other drinks don't do this. Tea stays light or amber. Juice looks like the fruit it came from. Even chocolate milk is still clearly brown. So what happens to coffee? Does something change chemically? Does it burn? Does it oxidize? Or is your eye being fooled? If you enjoy uncovering the hidden reasons behind ordinary things, take a second to like the video and subscribe. Because today, we're answering a deceptively simple question. If coffee beans are brown, why does coffee look black? Here's the first thing most people don't realize. Coffee isn't actually black, it's dark brown. Extremely dark brown. So dark that in most situations your eyes can't tell the difference. Color isn't just about what something is made of. It's about how light moves through it. And this is where coffee becomes interesting. When light hits an object, three things can happen. Some light is reflected, some is absorbed, and some passes through. Your eyes judge color based on how much light comes back to them. Now, think about a dry coffee bean. Light hits the surface, reflects off it, and your eye sees brown. The bean is solid, but its surface still reflects enough light for your brain to register color. But coffee in liquid form behaves very differently. Once you brew coffee, you're no longer looking at a surface. You're looking into a liquid, and that liquid is packed with microscopic particles. During roasting, coffee beans undergo complex chemical reactions. One of the most important is the Maillard reaction, which creates hundreds of dark-colored compounds called melanoidins. These compounds are responsible for coffee's deep color, rich aroma, and bitter notes. They're present in the bean, but they're trapped inside it. When you brew coffee, hot water pulls those compounds out, and it doesn't stop there. Coffee extraction also dissolves oils, acids, sugars, and tiny suspended particles into the water. The result is a liquid so dense with light-absorbing material that very little light makes it back to your eyes. So instead of seeing dark brown, your brain simplifies the signal. It looks black. This effect becomes stronger as the liquid gets deeper. If you pour a thin layer of coffee onto a white plate, you'll notice something interesting. It looks brown. But inside a mug, where the liquid is several centimeters deep, light can't pass through the entire volume. Each layer absorbs more light than the last. By the time light reaches the bottom and tries to come back up, there's almost nothing left. Your eyes interpret that absence of reflected light as black. This is why coffee can look black even though it isn't. And why dilution changes everything. Add milk, and suddenly the color lightens. Add water, and it turns transparent brown. Nothing new is happening chemically. You're just changing how much light survives the trip. But there's another detail that pushes coffee even closer to black. Roasting. The darker the roast, the more melanoidins and oils are produced. Dark roasts release more of these compounds into the brew. That means more light absorption, more opacity, and a drink that looks even darker. So when people say coffee is black, they're not describing a pigment. They're describing a visual illusion created by concentration, depth, and light absorption. But here's where most people get confused. If coffee only looks black, why does it feel so consistent across cultures and brewing methods? Why does almost everyone describe it the same way? That question leads to a deeper idea about how humans perceive color itself. And that's where this story really gets interesting. This is where our perception does most of the work. Human vision isn't precise. It's efficient. Your eyes don't measure color in exact wavelengths. They compare contrast. When something reflects very little light, your brain stops trying to identify subtle differences and labels it as black. That's why shadows look black even though they're not. That's why deep water looks black even though it's clear. And that's why coffee looks black, even when it isn't. In reality, coffee sits right at the edge of human perception. It's dark brown enough that, in most everyday situations, your brain treats it as black. This becomes even more obvious when you compare coffee to other liquids. Tea, for example, has far fewer suspended particles. It absorbs less light and lets more pass through. Wine is deeply colored, but still transparent. Light can travel through it and bounce back. Coffee doesn't give light that chance. Its suspended particles scatter and absorb light in all directions. Instead of passing through, light gets lost. This effect is called optical density. The more stuff a liquid has floating inside it, the darker it appears. Coffee is unusually dense in this way. Now here's something most people never notice. Coffee doesn't look equally dark everywhere. Look at the edge of a cup where the liquid is thin. Suddenly, you can see brown tones. Look at the center, where it's deepest. It looks black again. Same liquid, different thickness. That's the illusion. And this illusion became part of how we talk about coffee. Black coffee doesn't mean the color black. It means coffee without milk. The phrase stuck, and over time, the idea did too. Even lighter roasts can look black in a mug. Even weaker brews can appear dark if the cup is deep enough. So the color we associate with coffee is less about chemistry and more about context. But roasting still plays a role. As beans roast, they break down sugars and amino acids into darker and darker compounds. These compounds not only darken the bean, but dissolve easily into water. That's why espresso, which is highly concentrated, looks almost ink-like. Not because it's blacker, but because it's denser. This is also why cold brew often looks darker than hot coffee. It extracts fewer acids but more heavy compounds, increasing opacity. Same bean, different perception. And here's the deeper takeaway. Coffee didn't change color. Your relationship with light did. Once the bean is ground and dissolved, you stop seeing a surface and start seeing depth. And depth changes everything. So when you look at a cup of coffee and call it black, you're not wrong. You're just using a shortcut your brain has always relied on. The simplest explanation that works. And that's the real lesson hiding in this question. Many things in everyday life don't change as much as we think they do. What changes is how we see them. The angle, the thickness, the light. So the next time you pour a cup of coffee, take a second to notice the edges. That thin brown line near the rim tells the whole story. The coffee was never black. It just became too dark for your eyes to argue with. If this made you look at your morning coffee differently, leave a like, subscribe, and share it with someone who drinks coffee every day. Because sometimes the simplest questions reveal how much of the world exists only in our perception.